Well, we have one last set of three pieces of information that we might have matching up congruent between two triangles to investigate, and that is if we have all three angles to match up. Of course, we know because of the triangle angle sum theorem, if we have two angles, we can figure out the third angle by subtracting from 180 degrees. So anytime we have two triangles with any two angles that are the same measure, two pairs of congruent angles between the two triangles, the third pair has to be congruent as well. So really, if you got angle-angle, you have angle-angle-angle condition. So in this one, you can specify two angles. So we start by making an angle here at angle A, and then we have an angle for B. But notice that no matter where, we can pick wherever we want on this side and make that angle, and we can get a triangle. So in this case, there are actually infinitely many triangles with those same angles. So angle-angle or angle-angle-angle is never going to be enough to lock down the triangle size at all. It'll lock down all the angles, of course. Just knowing two angles will lock down the third one as well. But the sides could be anything you want. Well, let's say one of the sides can be anything you want. This one at the bottom here. Once it's fixed, then of course then the other two sides are fixed as well. But we have any one here. Now here are some side lengths right at the moment. Let's see if I can experiment with this a little bit to make this a little bit easier. Okay, so suppose we have side A is 2. That's this side here. And here B is 3.13. C to here, to B1, is 3.9. But in the bigger one, we might have something bigger. We might have A is 4, let's say. I can get it there. So we could have A is 4 across here, A2, which is twice as big as the one here. Well, look what happens to B. B is 6.26, where this is 3.13. Do you notice anything there? This is 3.9. This is about 7.8. Well, one thing you may notice is that these side lengths are in the same proportion. They're proportional side lengths. In other words, if we take a side in the triangle 2 and divide it by the corresponding length in triangle 1, we get the same number. 4 divided by 2 is 2. 6.26 divided by 3.13 is 2. 7.8 divided by 3.9 is 2. So we get every measure in this case the bigger triangle is twice the measure of the same corresponding length in the other triangle. So everything's twice as big in terms of lengths, but angles are exactly the same. So this is what we call, these are not congruent triangles, these are what we call similar triangles. Of course, it does include the case where you might be, similar triangles includes the case where this proportionality constant is 1 and then the same triangle, that's congruent of course. But otherwise they're not congruent, but they are what we call similar triangles. Okay, let's continue with this and let's try to make some triangles of your own. Okay, and see if you can come up with this. So what if I say 20 and 190 degrees? Well, this is already above 180 degrees, or if we do 20 degrees, even 170 or 160 even, that's already 180 degrees for those two. There's not enough room for the third one. So we know those situations are not even possible. But if we have a situation, as long as these don't add up to more than 180 degrees to start with, let's say 20 degrees and 100 degrees, that's 120. So that forces the third angle here to be, what is it, 180 minus 20, 60 degrees. Okay, see if you can construct a couple of different triangles with these angles, 20 and 100. Of course, the other one's going to be 60. And just use your straight edge and your protractor to do this, and then measure all the sides, and then compute some of the ratios. Go ahead and do this, and then come back in a minute. Press pause now. Okay, so in this case we want a 20 degrees and 100 degrees, so I can type in this box 20 and in this box 100, and that specifies the two triangles. The red angles at B here and B1 and B2 are both 100. The blue angles down here at A, and A1 and A2 are 20. And then it so happens that the one at C then has to turn out to be 60 degrees that we just discussed. But I can change the size of this one. I can change the size of this one. Okay? And right at the moment, let's see here. See what I can do here, if I can make this. There we go. So now I've figured out the ratio is 3. So here are the side lengths, and here are the ratios. And we see that that everything in the big triangle, every length, well, I moved it, now it's not true anymore. It's 3. Now it's 2.79 times as big. I'll get it back to 3 if I can. Okay, now it's back to 3. So everything in the bigger triangle, triangle 2, is 3 times as big as the one in the first triangle. That's not true. Not everything. The angles are exactly the same. The lengths are 3 times as much. So A2 is 3 times A1. B2 is 3 times B1. C2 is 3 times C1. But one thing is interesting here, we can also do some other ratios. What if we take within the same triangle, we take A1 divided by B1? That's 1.16 divided by 4.64. You might try that on your calculator. When you do, it should get approximately 0.35. Let's do the same thing for the other triangle. A2 divided by B2, and notice that turns out to be 4.83 divided by 3.9. Hey, that turns out to be 0.35 as well. And if we do A divided by C, whether it's A1 divided by C1 or A2 divided by C2, we get 0.39. And we do, let's see, what's another one we could do? We could do maybe B2 divided by C1, or B2 divided by C2, B1 divided by C1. Either way, you get 1.14. And notice that doesn't change, even though this ratio here changes when I change one of these. These numbers here don't change. They only change when I change the number here. Okay? And so there I happen to pick one that was isosceles, so the ratio of these two sides is 1 because we have a pair of congruent sides, pair of congruent angles. So change it again. Now these ratios change, but they don't change whenever I change this side, the measurements here. The ratios from triangle to triangle of corresponding things are the same no matter which ones you pick, but they're different for different sized triangles. The ratios of a side to another side within a triangle don't change as we change the size of the triangle. So this is what we have when we have what are called similar triangles. We have these proportionalities here, these proportions on these these ratios that are equal. A1 over B1 equals A2 over B2. And A1 over C1 equals A2 over C2. And B1 over C1 equals B2 over C2. And then we also get A2 over A1 equals B2 over B1 equals C2 over C1. So we have those fractions, those ratios that are equal. Those are called proportions. And so our sides are proportional, but our angles are the same. So angle does not give us congruent triangles, but it does give us similar triangles. And actually this angle property is really the main key to making a lot of trigonometry work. So we're going to build on this property in our next section as we introduce trigonometric functions.